Hey everyone, Mr. Schultz here as we dive into function families. Make sure you put your name and period at the top. Our learning objective is to be able to describe polynomials from their equations. So remember back this definition. For every input x, there's exactly one output, which we will refer as y or f of x. This is the definition of a function. So let's dive into this. So we have first thing we have the identity function. So this is one of the first equations we learn. This is a linear equation. It's going to look like a line. The parent function to this looks like this. And all the offspring of this parent function all derive from this x to the first power right here. So anything that has the highest degree of to the first power is going to be a linear equation or an identity equation. So could be y is equal to 4x plus 2, or even negative 3x minus 5. It could be plus 5. It doesn't matter. We look at the degree. This one would be 1. This one would be to the first power. Now the next one we have is the squaring function. That means timesing to itself. Now we call these the quadratic equations. That's where the parent looks like this, x squared. Now if it looks like a u going up, it's most likely going to be squared, but it could be something else. Now it could also be pointing down for some reason. We'll get into that. So as long as it has the highest degree of being x squared, you're good. But it could look like this. It could have the x and it could have like the constant, like a 5 or minus 4. Now this leading coefficient right here, we'll care about that. We'll care if it's negative or positive. We'll get to that and why that's important. The next family function is called the cubing function. This is when we get into cubic equations. This is when we have something times itself, or x cubed. This is the parent right here. And the offspring to this guy could just be x cubed, maybe plus 4. Or it could have everything from x cubed all the way down. So x cubed plus 4x squared minus 5x, and then I could have plus 7. It doesn't matter. All I really care about is what's the highest degree. And I will want to know about the leading coefficient. Is it positive or negative? For this one, for the odds, we're going to start learning about the turnarounds, how many, and which will help with figuring out the relative minimum extrema. So right here, if you look at this x, 1 minus 1, tell me what 1 minus 1 is. So that means it's going to turn around 0 times. Now if I look at this x squared, it's going to turn around. 2 minus 1 is 1. It's going to turn around once. Now x3, 3 minus 2, or I'm sorry, 3 minus 2 is, 3 minus 1 is what? There we go. So that means this is going to turn around 1, 2. Now, in certain situations, it's going to start from the top, coming down. So it's going to turn around once, twice, and come down. And we'll explain when this happens in comparison to these two right here. Now, at this point, we kind of stick at this like anything past this kind of relates to the previous ones. We have linear, and then we have the squared and the squaring, and then we have the cubing, also known as the quadratic and the cubic. So this quartic function, or this quartic equation, is going to look like this, x to the 4th. And in a lot of the situations, it's going to look like this. It's going to look like a u, but it's going to look like it has a, it's going to look a little more weird. Why? Well, if we have more of these, and I'll write them in, like x to the fourth plus x to the third minus x squared plus x minus 3. Let's just say, for example, well, that's going to give us some more opportunity right here. Oop, let's erase that. It's going to look like this. It could start like this, and it's going to turn around. 4 minus 1 is 3. So it's going to turn around once, twice, and then 3 times. So if it's even, it's going to point up. So x to the 100th power, point up. X squared, point up. Both sides. As x decreases, it's going to increase, y is going to increase. As x increases, y is going to increase. Now we have the quintic function and quintic equation. That's x to the 5th. So I could have this mean x to the 5th minus 3. It doesn't really matter. I just look at the highest power and what's the leading coefficient. And for this one, if I times a negative 100, let's try this. If I plug in negative 100 and I times it to itself 5 times, a negative times a negative times a negative times a negative times a well, 2 negatives make a positive, 2 negatives make a positive, and I'm left with a negative. So if I'm going negative, a really small negative number, well, then I'm going to get a really small output. And if I times 100 by itself, 100 times 100 times 100 times 5 times, I'm going to get a really big number. So what's going to happen is I'm going to get something that looks like this, but it could look with at the most 4 of these turns. Why? 5 minus 1 will turn this 4 times. I'm going to turn around 4 times. So I'm going to turn around once, twice, 3 times, and 4. Now, it doesn't necessarily have to look like that, but it could look like that. Now, let's go on. So we can graph every equation. I'm going to show you some points right here. I'm going to plug in negative 2. I'll plug in negative 3 over here. I'm going to plug in negative 1. I'm going to plug in 0, 1, and 2. I'm going to show you the work, but I'm going to pause it so you don't have to see like the 2 to 4 extra minutes I'm going to do with this. But I'll show the work. All right, guys. So if you look at this, I've shown my work to figure out 1, 2, 3, 4, 5, 6. And if I plug these in, if I plugged in negative 3, I'll get 1, 2, 3, 4, 5, 6. If I plugged in negative 2, I should get 2. If I plugged in negative 1, I should get 0. If I plugged in 0, I should get 0. If I plugged in 1, I should get 2. And if I plugged in 2, I'm going to tell you right now, 2 times 2 is 4, plus 2 is 6. I should get 6 right here. So looking at this, it looks like I have an axis of symmetry right here. And I should have somewhere around here, I should have my vertex right about here. Right here, probably at negative a half. Now, I don't have time to graph that. It took me a little while to graph every single point and then be like, hey, look, this right here as x. So if I was going to describe this, I would say, hey, as x approaches infinity, let's go left, negative infinity, because we have negative infinity. So over here, I'm going to draw this out. I'm going to draw a negative infinity. I'm going to draw a positive infinity this way. I'm going to draw a positive infinity this way. Well, that was a bad one. Okay. I'm going to draw a negative infinity. So as x goes this way, f of x, or y, is approaching positive infinity. And as x approaches infinity, as x goes to the right, is it going up or down? It's going up. And that's where positive infinity is. So I'm going to say y is going to approach positive infinity. Now, I don't need to draw this as long as I understand a few things. Let me show you some of the basic things we're going to do. Let's go down and do it. All right, so let's simple rules for figuring out n behavior. First, what is the highest degree of the polynomial? Don't worry about the other ones. And second, is the leading coefficient positive or is it negative? So if I look at this, I don't care about this stuff. I'm going to look at this. So I know as I input a number, it's going to go like this. If I input a large value for x, I should get a large value for y. If I input a huge negative number, like negative a million, I should get a negative output. So it should look like this. But it's going to be to the first power. And I'm going to see, hey, this is positive. This next one, 10x cubed minus 16, well, let's hold up. For the next few, I'm going to I'll copy and paste from Desmos, and I'll show you what it looks like. And then you can draw a rough sketch of it. Don't worry about the numbers, just draw a rough sketch. So for the next ones, I'll do that. All right, guys, so if we look at this, x to the first looks like this, 10x to the third, we're seeing that, hey, look, it's going up to the right, and down it's going down to the left, down to the left, up to the right, when it's an odd number. But as it increases, this part right here looks like it's getting longer and flatter. Let's look what happens for even powers. So if it looks like it's even, it's going to be pointing up. But we'll talk about that in a second. So this U-shape, this parabola U-shape, actually looks like it's getting flatter and flatter. But in each of these cases, as it's going left or right, it's going to go up. So the output is increasing as x decreases or increases. Now let's show you what happens when the graphs, the leading coefficient is going to be negative. So instead of positive 2x plus 45, it's now negative 2x. So let's look at these, and we're going to see what happens. What should happen is that it flips. Let's show you. So here's what happens. So instead of odd, as we go left, it's going down, and as we're going right, it's going up. It now switches. So now for the odd ones right here, we're going to notice that it's going to go up if, the odd powers, so 1, 3, and 5, if this leading coefficient is negative, if it's negative, it's going to go as x decreases, y is going to increase. As x goes to positive infinity, as x goes to positive infinity going to the right, then it's going to be y, or the output is going to go to negative infinity. So same thing applies. As x decreases, y increases. As x increases, y decreases. So the exact opposite. So since this is negative, it flips. So we would draw our information, and then we would draw our first graph and then flip it. So kind of a rough draft of it. So, and what I'm talking about is, like, we should start off with x squared looking like this. We should draw x to the fourth looking like this, and then x to the sixth looking like this. And then figure out, hey, look a second, they're negative, so then we flip it. So as x decreases, y decreases. As x increases, y decreases. So we'll talk about that in another video. As x decreases, y decreases. As x increases, y decreases. All right, let's go on to our last page, and then you have your homework. So So draw a rough draft using the highest degree. If the highest degree is even, draw it. If the highest degree is odd, draw it. Let's see if you're right. In 3, 2, 1. So I don't know. If the leading coefficient is positive, then they should be pointing up, both sides. If the highest degree is even. Now, if the highest degree is odd, as it goes left, it's going down. As it goes right, it's going up. Now, we would have to understand, like, look at the highest degree, and if it was like x to the fifth, then it could turn around 4 times, like 1, 2, 3, and then 4, and then be pointing up. But it doesn't necessarily have to look like that. It could look flat. Remember x to the 6th had that flat bottom right there? All right. So let's look at the leading coefficient. If we're looking at the leading coefficient, we're going to want to know in the front of the highest degree variable. We don't care about the other ones. We just care about the highest degree variable. If it's positive, you're going to want to leave the graph alone. Leave it alone. So looking at this, if it's positive and it's even, it's going to look like a U, and it's going to be pointing up. Or if it's positive and it's odd, it's going to look like that. Leave it alone. Don't touch it. If it's negative, you're going to flip it over. Let's do a quick little test run of this. So I have 3x squared plus 6. I don't care about this plus 6. It's going to move it up, but forget that. I only care about end behavior. So I don't even care if that's a 3. I don't. So the first thing I see x squared. So I know it's going to look like this. Now I check. So I did this one. Now I check and I see that 3. So what I'm going to do is I'm going to see, is it positive or negative? It's positive. So it's this. So we're going to talk about this later, but as x is increasing, as x approaches infinity, positive, as x goes right, then the y is going to approach positive infinity. As x approaches negative infinity, is the graph going up or down? If the graph's going up, so the output is going to approach positive infinity. Okay. Now for this one, we would do the same thing. We'd be like, all right, first up, it looks like x squared, so it's going to look like u. And then I look at the coefficient and I see it's negative. So now I know it's flipped. So I'm going to do a little cross out. I'm going to flip it over. And now I can talk about this way. So no matter what, y is it's going down no matter what. So y is going to negative infinity. Y is going to negative infinity. Because it's going down forever. In any direction we go right, going down. We're going left, going down. So as x goes left, as x approaches negative infinity, y approaches negative infinity. As x approaches positive infinity, y approaches negative infinity. Okay. So I want you to explain in 2 sentences how you can informally draw these polynomial graphs we just did. Remember, we're talking about, is it an even or an odd power? And we don't care about the number of the coefficient. We care about the value, specifically positive and negative. Go ahead and explain, and I'll see you guys in class. Bye.